Greetings. Today we're going to continue our discussion of acids and bases, and we're going to talk about weak acids and strong acids, or strong acids and weak acids. So what are strong acids? Strong acids are those acids that completely dissociate. By now you know what acids are. One of the common traits, remember, is they have H in the beginning, of course, except for water. For the most part, that's a way to identify them. Now, you all are familiar with high school romances. Well, I hate to tell you, they don't last very long. Not 20, 30, 40 years. So these couples that were so sweet in high school, they tend to dissociate. They separate. All right, so in light of that, we're going to talk about the dissociation of HCl. Notice that HCl is a gas. When we place it in water, when we blow it into water, it dissociates into H plus ions dissolved in water, this meaning AQ, plus Cl minus AQ, meaning dissolved in water. This means that there has been a dissociation. They have separated. They were a couple, and now they have separated. Now, strong acids dissociate almost 100%. So, of the molecules, maybe we're going to say that of 100. If an acid dissociates 100%, that's a very strong acid. Most strong acids, though, dissociate at a rate of 99% to 1%. 1% does not separate. Okay, so that's probably about the rate of couples in high school. 99% dissociate, and maybe 1% stays together. By the way, I'm part of that 1%, even though we wasn't in the same high school. I can tell you about that later. All right, so here's a table of strong acids. All of these acids are very strong. Why are they strong? Well, simply because they dissociate at a very high rate. 98%, 99%, maybe even 100%. Notice that we have hydroiodic acid, hydrobromic acid, perchloric acid, hydrochloric acid, chloric acid, and sulfuric acid. What does that mean? Well, this is the dissociation that I am showing you. This is the way the reaction goes. And the next one, and notice HCl, this is what I just showed you, the dissociation of the ions. Notice HClO3 dissociates H plus and the ClO3 ion, the polyatomic ion. So remember your polyatomic ions, the hydrogen will dissociate away from the polyatomic ion. And finally, H2SO4. That's a little unusual because first you have the dissociation of one of the ions and then a second ion possibly. But they stay, one of the hydrogen ions stays with the SO4, at least initially. All right, so it can contribute additional protons. The HSO4 can contribute additional protons. So all of these, there's one more down here that you cannot see, but now you can, maybe. This is nitric acid, and nitric acid dissociates to form H plus NO3 AQ. So notice all of them dissociate in the same way. So then, what are weak acids? Weak acids partially dissociate. That means that most of the compound will stay together. They will not turn into ions. let's show a dissociation of acetic acid. And I'm going to write it right here. HC2H3O2. All right, this acid dissociates in the same way that you would imagine H plus, AQ plus the acetate ion minus. Notice that there's a double arrow. That means, that double arrow means that it's reversible. So as the ions dissociate, they get back together. But the point is that most of them will stay together as the original molecule, the acetic acid. A few will dissociate. So that's why acetic acid, which is also found in vinegar, this is how vinegar is made. Vinegar is 5% acetic acid, and it's a weak acid. So we can actually ingest it. 98% of the couples and 2% singles. So here they stay together and 2% may dissociate. These are weak acids. Now, this is a list of strong bases. And these strong bases have something in common, and I'm going to ask you about that. Strong bases are pretty much the same as strong acids. They behave in the same way. Bases, notice, most of them contain OH, the hydroxide ion. Therefore, the dissociation goes in this direction. NaOH, NaOH minus. They dissociate. KOH dissociates into K plus and OH minus. LiOH dissociates into Li and OH ions. Rb and OH. CS and OH. Calcium, notice, it's not very soluble, but it's still listed as one of the strong ones. And even though these are not very soluble, we can consider them in the strong base list. All right. So again, what's a strong base? Once it dissociates greatly, most of the ions will be dissociated when they're put into water. All right, so here I have an example of a weak base. NH3. This is ammonia. Notice that we do not use the stock name for ammonia. We use a particular name for this compound, which is ammonia. And you need to remember, just like water is water, okay? And notice that it can also be written, water, of course, H2O, as you already know. It can be written as HOH. It's helpful because it helps us to see how this reaction is going to work. So, what happens here is that the hydrogen is stolen from the water, and we end up with NH4, and this is AQ, dissolved in water, plus OH minus AQ, dissolved in water. This is jumping a little ahead because these are chemical reactions, and it shows you how these dissociate, but you can understand that this is the beginning reaction, this is the end product, and this would be the reactants and then the products on this side. All right, so that's the dissociation of ammonia, which is a weak acid because it goes in both directions. In other words, we have reformation of the original compounds, which are NH3 and HOH. All right, don't worry too much about these. For now, all you have to do is know which ones are strong and which ones are weak acids. and strong acids and weak acids, keep in mind that strong acids and strong bases have weak bonds because they don't stay together. Just like high school sweethearts. Not very strong bonds. They just don't stay together. Okay. Well, I'm going to explain to you what you've been hearing about dissociation and strong acids versus weak acids. So here we have a strong acid, okay? And then we're going to just pretend that we have this is the formula of it, or this is the structural formula of it. And here we have a weak acid. All right, don't go anywhere. All right, so basically what I'm going to do is I'm going to take my acid and place it in water. And let's pretend that this beaker contains water. And if it is a strong acid, what's going to happen is they are going to separate. Okay, so the strong acid completely or almost completely separates. And there we go. Okay, we don't want those. All right, and a few of them will end, well, one of them out of all these will end up like this. So this is what's going to happen in dissociation of a strong acid. Almost all of them, 98% of them, will split up. It's like couples. I don't know too many couples that stay together beyond high school or for many years after high school. So you could say that they dissociated, they separated. All right, and in this case, we have a weak acid, and the weak acid is not going to dissociate very much. Some of it will, and the ions will separate, but the vast majority of them will remain bonded. Oops, should have kept that one together. Okay, the majority of it will be bonded together. All right? Okay. See you tomorrow.